Okay, let's recap the lesson. So first of all, it's a navigation problem, but it's going to have all of our laws and all of our rules in it. So let's take a look at it. Two ships leave port at the same time. Here's port. Ship A travels on a bearing of north 25 degrees east. So it's facing north and rotates 25 degrees towards the east. Okay, there's north, east, south. Okay. Now, I'm going to draw at 12 knots, but 12 didn't quite fit on my page, so I scaled it down. So drawing at 12, I really drew at 6 and called it 12. Ship B travels south, and it's going to rotate 40 degrees towards the east. Okay, and so then I get my 40 degrees there. It is 8 knots, but since I scaled the one, I scaled the other, so drawing at 8, I drew at 4 and called it 8. Okay, now, since I'm going to go for 3 hours, I didn't want to draw it 3 times as long. I just multiplied it. So it's like scaling, or I zoomed out, 36. So 3 hours times 8 is 24. Okay, so now I know in a right triangle, 40 and 90. Okay, I need to know that's 50 degrees, 65 because of the 25 and 65. Okay, so this full angle here is 115. Now the two ships are this far apart. Okay, how do I find the distance apart? Well, I just use the law of cosines. I've got my opposite squared, so I want this distance is equal to adjacent squared plus the other adjacent squared minus 2 times the adjacent times the other adjacent times the cosine of the angle. I put that in my calculator. I got about 2,602, and I took the square root of that because it's p squared. I got about 51 knots. Okay, so that's question 1. Not too bad, just takes a while to draw correctly. Okay, now on the back side I have this quadrilateral. So to find the area of it, I know the area of a triangle is 1/2 adjacent times the sine of the angle. So I cut it down, not necessarily in half, I just cut it into 2 triangles, okay? The first triangle, that's not too hard because I have the adjacent, and I have the angle. So I'm just going to go straight to get in the area of the first triangle. I'm going to go 1/2 my adjacent, which is 20, times my other adjacent, which is 20, times the sine of the angle. I used my calculator and I got 214, okay? Now, triangle 2, I don't know a lot about it. I don't have a lot of information. So the first thing I want to do is find this side, okay? I called it C. And for the first triangle, I've got my opposite squared equals my adjacent squared plus my other adjacent squared minus 2 times my adjacent times the cosine of the angle 130. Put it in my calculator, and I got 1,903.9, but then it's C squared, took the square root of that. So this is 43.6 is the length of this diagonal. Okay, now I really want to use this formula here, 1/2 adjacent sine. So I have my adjacent, but I don't have my angle. This 110 degrees is for the entire angle here. So what I need to do is find this angle in this smaller triangle. Once I find that, I'll subtract it from 110. So I did that. In this small triangle, I had opposites, so I set the law of sines, sine of 20. Let's see if you can see this. There you go. Sine of theta over 20 equals sine of 130 over 43.6. I solved for theta, multiplied up to 20, got my decimal, went sine inverse, and I got this angle, 20.6. So that angle is 20.6. I subtracted 110 degrees from that, so 110 minus my 20.6 gave me my 89.4. Okay, that's my angle. Now triangle 2 I can do. I have my adjacent, I have my other adjacent, I have my angle, so I just put my 1/2, my adjacent, which is 43.6 times my other adjacent, 25 times sine of 89.4, and I got the area of triangle 2. Now I've got the 2 triangles, okay, and I'm just going to add triangle 1 plus triangle 2, 214 plus 545 is about 760.5. Okay, so that is the lesson. If you have any questions, please ask. These are kind of hard